today we're going to be discussing the transformation of a function or of functions. I'm going to use one function as an example, but these rules apply to any given function. So the function we're going to be using and transforming is y is equal to f of x, and our graph is 2 to the power of x. It's an exponential function. But what I need you to pay attention to are these following coordinates, which will help us when we're transforming or to look at our transformed functions. So as we can see, at x is equals to 0, f of x is 1, and at x is equals to 1, f of x is 2, and x is equal to 2, f of x is 4. So we're going to be looking at these three particular points when we look at our graph transformations. So these are the 10 transformations that we're going to be applying to the graph of y is equals to 2 to the power of x and the effects that each transformation has on the graph. For example, the fourth transformation is y is equals to fx minus c, which shifts the graph of f of x at distance c units to the right. So you will see all of these as I go through them. Now, if we look at this transformation where it says y is equals to f of x plus c, and I have chosen for all these transformations for c to be equal to 2, right? So what that gives us for our function, which is y is equals to 2 to the power x, it says that y is equal to 2x plus 2. Right. So from our list of transformations, the effect of this transformation is that it shifts the graph of f of x 2 units upwards. So now let us look at our value of, so green is the original graph and red is the transformation, so that you can see. Let's look at where at x is equal to 0, y was equal to 1. But now at x is equal to 0, y is equal to 3. So it has moved 2 units upwards. It has shifted 2 units upwards because our c is equal to 2. Let's look at x is equal to 1. It was 2, but now it is at 4. So it has shifted 2 units upwards. Similarly with 2, x is equal to 2. It was at 4, but now it is at 6. So now we see that the transformation says you shift the graph 2 units upwards by the factor of c. In our case, the factor of c is 2. Now, when we look at the transformation of y is equal to f of x minus c, which is going to give us y is equal to 2 to the power of x minus 2, c still being equal to 2, our graph according to the transformation is shifted 2 units downwards. So green still being the original graph and red being the transformed graph, we can tell that this graph has moved 2 units or shifted 2 units downwards, because when we go back to look at x is equal to 0, y is now negative 1. And when we look at x is equals to 1, it went from 2 to 0. And then x is equal to 2 went from 4 to 2. So the graph has been shifted 2 units downwards. Now we're going to look at the transformation of y is equal to f of x plus c, which turns our graph to y is equal to 2 to the power of x plus 2. So now the 2 is added to the exponent because we are adding to the x directly, not to the entire function. So now what this transformation does, or the effect of it, is that it shifts this graph 2 units to the left. So again, we're going to look at our particular unit values. So our y is equal to 4 was at x is equal to 2, but now it is at x is equal to 0. So it moved 2 units to the left. Our y is equal to 2 was at x is equal to 1, but now it is at x is equal to negative 1, so it has moved 2 units to the left. And then our y is equal to 1 was at x is equal to 0, but now it is at x is equal to negative 2. So the graph has been shifted 2 units to the left by the transformation y is equals to fx plus c. Okay, so now when we look at this transformation that says y is equals to fx minus c, it gives us the resulting function y is equals to 2 to the power of x minus c. So the effect of this transformation is that it moves the graph 2 units to the right. So let us look at our key points. Y is equals to 1, which was at x is equal to 0 is now at x is equal to 2. And then y is equals to 2, which was at x is equal to 1, is now at x is equal to 3. And then y is equal to 4, which was at x is equal to 2, is now at x is equal to 4. So everything has shifted 2 units to the right. So now for this transformation, which multiplies the graph of x by c, for us c is equal to 2. So now we have y is equal to 2 times 2 to the power of x. So for x is equal to 0, we're going to have y is equal to 2 times 2 to the power of 0, which is equal to 2 times 1, then y is equal to 2. And then for x is equals to 1, we're going to have y is equals to 2 times 2 to the power of 1, which gives us 2 times 2, giving us y is equals to 4. X is equal to 2, we have y is equals to 2 times 2 squared, which gives us 2 times 4, and that is 8. Let's see if those points are on our graph. So x is equals to 0 went from being 1 to 2, and then x is equals to 1 went from being 2 to 4, and then x is equal to 2 went to being 4 to 8 as according to our calculations. So with this transformation, our graph has been stretched by the factor of c vertically, has been vertically stretched by the factor of c. Okay, now for this transformation, which divides our graph of f of x by the factor of c, so what we get is y is equals to a half times 2 to the power of x, right? So for x is equals to 0, we get y is equals to 1 over 2 times 2 to the power of 0, which equals to a half. And then for x is equal to 1, we get y is equals to 1 over 2 times 2 to the power of 1, which equals to 1. X is equals to 2, we get y is equal to a half times 2 to the power of 2, which is y is equal to 4 divided by 2, which is equal to 2. So now let's look at our graph and how it has moved. X equals to 0 has moved to 1 to a half, and then x is equal to 1 has moved from 2 to 1, and then x is equal to 2 has moved from 4 to 2. So our graph has been shrunk by the factor of 2. Basically, it has been shrunk by a half. So that is the effect of this transformation. This transformation, what this does is divide x by 2. So we're going to have y is equals to 2 to the power of x divided by 2. So for x is equal to 0, we're going to have y is equal to 2 to the power of 0 divided by 2, which is still equals to 1. And then for x is equals to 1, we have 2 to the power of a half, which is equals to 1.4 point something. And then for y is equal to 2 to the power of 2 divided by 2, it's equal to 2. Alright, so let's look at our values on the graph. And for x equals to 0 hasn't changed, it stayed the same. But y equals to 2 has moved from being at x equals to 1 to x equals to 2. And then y equals to 4 has moved from x equals to 2 to x equals to 4. So what this transformation does to your graph is that it stretches it horizontally. It has a horizontal stretch effect on your graph. Now for this transformation, we are multiplying x by c, and we will get y is equal to 2 to the power of 2x. And then for x is equal to 0, we get 2 to the power of 2 times 0, which is still equal to 1. And then y, for x is equals to 1, we get y is equals to 2 times 1, which is equal to 4. So for x is equals to 2, y is going to be equal to 2 to the power of 2 times 2, which is 2 to the power of 4, giving us 16. So now when we look at our key points again, at y is equal to 0, we're still at 0 because it hasn't changed. Now at x equals to 1, we now have 4. And at x equals to 2, which is way up there, we would have 16. So as you can see, the graph of x at this point has been drawn inwards. So the effect of this transformation shrinks the graph horizontally. Now for this transformation here, the effect of the transformation is that f of x is reflected about the x-axis. So now we're going to have y is equal to negative 2 to the power of x. As we can see, at x is equal to 0, now y is equal to negative 1. At x is equal to 1, y is equal to negative 2. And at x is equal to 2, y is now equal to negative 4. So all that happens here is that the graph of f is reflected about the x-axis. And now for this transformation, we get x made negative. So we're going to have y is equals to 2 to the power of negative x. And the effect of this transformation is that it reflects the graph of f of x about the y-axis.